Okay, Aiden is saving for a future renovation project that is estimated to cost $46,000. How much will Aiden have to deposit at the beginning of every 3 months in order to accumulate $46,000 in 6 years? Interest is 5.87% compounded quarterly. Round the answer for payment to two decimal places. Okay, so this is a future renovation project estimated to cost $46,000. So this $46,000 here is a future value. So that is the goal, is to save $46,000 for this renovation project. So how much will Aiden have to deposit at the beginning? Now we go and we select begin. Beginning of every 3 months. So the deposits are every 3 months. So that would be 4 times per year. So PY would be 4. Payments or deposits, correct? That's how it's called. Now this is the interest right here, 5.87% compounded quarterly. So therefore CY is also 4. Now, and we usually use the calculator to do that. The IY value is 5.87. So we can copy and paste it so that there are no typographical errors. Now the present value would be 0 because they're starting from nothing and then making deposits. All right, and this is the future value right over here. This is the number that we will compute because the question is asking how much will Aiden have to deposit at the beginning of every 3 months in order to accumulate $46,000 in 6 years. So that is what we're after. That is what we'll need to compute is the payment. Okay, we have to get the calculator into begin mode. So we do that by clicking on second TMT and you see end. So to get that into begin mode, we click on second and then we click on enter and there begin is displayed in the top right corner. Now we could come out of here either by clicking here or clicking on second CPT, which will quit. All right, calculator is set to two decimal places, which is convenient. Okay, so we have the fours in there. All right, no, we haven't done that yet. Sorry, we just switched to begin. So PY is 4, and so is PY. So we can come out of here. Right, that has been entered. So we have begin and we have the PY and CY. Now, how many years is this going to be for? It's for 6 years. So we go 6, second, N. So N turns out to be 24, and that is the 6 years times the payments per year, 4, giving us 24. Now the IY value is 5.87. So 5.87, that is IY. All right, what's the present value? Well, the present value is 0. So we're starting the savings to save the money. And the payment is what we'll need to compute to accumulate $46,000. So 46,000, and that is the future value. And with that, we compute the payment. And the payment works out to be $1,589.47. Okay, so let us submit that and see if that is correct, and it is correct. All right, so there we are. So that will be done in 6 years. The deposit of $1,589.47 deposited every 3 months or 4 times per year. And of course, this is the interest rate, 5.87. Okay, so let's go to the next question. So here we have Roscoe and Kristen purchased an item valued at $180,000. Now that would be their present value, of course. So if we wish, we could take that number and paste it into the present value, but not quite, maybe. They paid down 19,800. All right, so from this, we would have to subtract 19,800. All right, and then what else is there? Well, it's financed at 4.6%. There's the interest rate that we can paste into IY, and it's compounded monthly, so that tells us what? Well, that's CY is 12. Okay, so to reduce the amount owing to $47,190, so that is in the future, so let's put that number in there. At the end of 2 years, okay, at the end of 2 years, what size of equal payments must Roscoe and Kristen make at the end of each 6 months? End of each 6 months, that is twice per year. So PY would be 2. Okay, and we can do the rest. So we are trying to do what? Well, we are what size of equal payments? So the what needs to be computed is, of course, the payment. All right, so let's start and maybe we can get somewhere. Now we are no longer in the begin mode. So this does not say anything about beginning. It says what at the end. You see what size of equal payments must Roscoe and Kristen make at the end. This right here, end of each 6 months. All right. So let's come out of here. We come out of there. Let's clear what was on the screen. And so we go second PMT, and that brings us in where begin is. And we go second, enter, and that clears out the begin. So we're back to end mode now. End mode, nothing gets displayed because that's the default mode. Okay, let's start now. So PY is 2. So we go second IY and we put in 2, enter for PY. We go down and PY is 12. So 12 and enter. CY is 2, CY is 12. Okay, and then we can come out of here. Now, this is for 2 years. Okay, so we'll use the 2 to calculate the value of n, second n, n. So n turns out to be 4. The 2 is multiplied by the payment per year. Okay, this is the interest rate, so 4.6 IY, and there it is. Now, present value, we have to do some subtraction here. So we will take 180,000 and subtract 19,800. And that gives us this number, 160,000. So this is equal to what? 160,200. You could put in a 0.00. All right, so here we go now. So we go in here and we delete. And there we are, $160,200 right in here. Payment we will compute. And the future value now, they would like to reduce the debt to 47. It has the objective of these payments to reduce the amount owing to 47,190 at the end of 2 years. All right, 47,190. Okay, but that's not all. Remember, oh, sorry, I didn't enter the value into the present value. So there we are, present value as now the 160,200. Now, these instructions are important also. Enter the present value as a positive value. So that is correct. It is positive. And then now we must enter payment and future value as positive or negative based on the present value being positive. Now, you have to think back about when we just started with compound interest. If the present value is positive, then the future value turns out to be negative. All right. So what it's saying there is that if we declare present value, positive value in the present value box, then the future value would have to be negative. So be careful when you enter that value, which we will do right now. So 47,190. Okay, so 47190, and we must make it negative and enter that as the future value. All right, and with that, we will compute the payment, and the payment turns out to be 31,007.31. Let's just take the numerical value and not be concerned about the sign there, but the sign is negative, so maybe for our own well-being, probably, since it's saying about positive and negative up here, it might be in our best interest to put that value in the negative as well. When you see the size of each equal payment, then we probably should even pay more attention that this number here will be a positive number. See, it says enter a positive value, so it's probably or most likely expecting a negative value up there. And let's submit it. We submit it and it is correct. Now, we may wish to try, what if that is positive? What if we submit again and we see that it is marked wrong? So the expectancy is to have a negative sign in there, right? So when you do the question, you please take note and enter the number in the box with that negative sign right here. Okay, so I hope that takes care of that. I hope that is clear. If the present value, enter the present value as positive, then the future value has to be negative. All right, so next question. Number 8. Nuka has already saved $14,850 in his TFSA. So we can say that, well, we have a present value, right? Good, yeah. It's in the TFSA today, tax-free savings account, and plans to continue to add on equal deposits at the end of every 3 months. So that means it would be 4 times per year. You're dividing 12 months per year by 3. This 3 right here. And that gives us the 4. Okay, that goes on for the next 7 years. So what quarterly payment is required? So quarterly payment, that is what we had before, is required to accumulate $69,000. Okay, so that is the accumulated value or the future value. All right. In total, accumulate $69,000 in total at the end of the 7 years. If the nominal rate of return on the investment is 4.48% compounded annually. So IY is 4.48 compounded annually, so CY should be 1. All right, now what is it that we are looking for? We are looking for the payment. Yes. What quarterly payment is required? All right. So the payment is what needs to be computed. So here we put in CPT. Now, what happens? What do we need to take note of? Enter the future value as a positive value. So there we have it. That one is positive. Now we have to fix the present value and payment as positive or negative based on the future value being positive. Now the future value is positive as it is here, and that's what we're instructed to do. then the present value should be negative. Okay, so now we can do some calculations. All right, we have enough data or information to start. So let's go second IY. So PY is 4. So we go 4 and we enter. And then we go to CY and it is 1. So it's 1. Enter. So PY is 4, CY is 1. And then we can just clear down here. So how many years? Well, it's the next 7 years. Right over here. The next 7 years. So we go 7, second, N. So that N value is 28. All right, interest is 4.48, so we can enter that 4.48. All right, and the present value is 14,850, 14850. And we make that what, negative. Okay, because the future value has to be positive. So the payment we will skip over, and then the future value is 69,000. So we go 69000, and we put that in for the future value. So now we can compute the payment, and there we are. Okay, let's compute the payment, and the payment turns out to be, shall we put in the negative sign, 1,497.92. And hopefully our numbers are correct. Let's see. All right, now it says what is the size of each quarterly payment required is, that is the number right there, but it has to be positive. Okay, so we can copy that and we paste it into there. We should come out with the correct answer. And if we submit it, the answer is correct. So what you saw here, the future value is positive. Previously, the present value was positive. So here we are, if you look at these carefully, future value is positive, present value will be negative. If we go back to the previous question, we have the present value positive, so the future value must be negative. And just pay close attention to put not only the signs for those, but also the correct values, the correct sign for the payment also. Okay, whatever turns up on the calculator, please insert it, and that is indeed the correct answer. Now, just another item, maybe you are wondering, well, what distinguishes what we were doing before with compound interest and now we're doing with these annuities. What you are finding here, maybe this is not such a good question. These ones we are finding the payment. Oh, look, it says what quarterly payment. Okay, so if we go back, here it's also how much, yeah. So these were all the same. We were all computing the payment. Right? It says this one was saying how much will Aiden have to deposit at the beginning of every 3 months. So you notice that the deposits are regular, meaning we do have a payment now. Previously, the payment was 0. All right, but now we do have a payment, and these payments are quite regular. If we go back, way back, this is one. This question here, we can actually do it, but what you will find out, an amount of 3,570 is deposited into an account. So that amount of money is a present value, right? So here we go. Let's put it in here, and that's the present value. Okay, note if you look on And these ones now, present value is 0. Okay, but here, that amount that's deposited is the present value. The payment is 0. Why? Because this is a one-time deposit. It is deposited into an account, earning 7% interest compounded quarterly. The compounded quarterly, remember, by the structure of the calculator, because the calculator does many operations. So it's built with all of these boxes. You might say registers or spaces to be filled in. And so this one by default is 4. But what you're learning is that when it's really the multiplication takes place with the payment per year, the PY value, as opposed to the CY value. See, but in the case, so to fix that with a compound interest, these two have to be the that is the structure. All right, so this one, the interest is 7%. There we are. And the future value, how much will be in the account? 6 years and 9 months, in 6 years and 9 months. So that is an accumulated value, as you've come to recognize, or future value, meaning what after 6 years and 9 months. Now we can do this question here. And what we would do is we would put 4. Well, we have 4 in there already. If not, you just enter the 4. And that automatically takes on the value for CY when it's entered for PY. So when 4 was entered for PY, it also was there for CY. Now the 6 years and 9 months, remember how we did that? You take the 9 months and we convert it to years by dividing by 12. We could press equal, or we don't need to. If we did, then you see it's 0.75 or 3/4 of a year. Then we add 6 and we get the sum, 6.75, and then we go second and n. And n should be the 27. IY is 7, so we can put in our 7 for IY. And then the present value is this number right here, 3570, right here. Let's highlight it so you can see it. 3570 as the present value. So we enter it's positive. Okay. 0 for the payment. So 0 for the payment, and then we are computing the future value. So we click on CPT, future value, and there you see the negative sign. All right, right there. So you can put that in. That is why the answer allows for positive and a negative. And if you were to submit this question, the question is correct. So there you are. That is, always remember, this is an example of compound interest. There is one deposit. These are examples of annuity. This payment is at the beginning. The payment can be at the end of the payment period, end of 3 months, 6 months, or weekly or monthly, or at the beginning of every 3 months, beginning of 6 months, or semi-annually, or monthly, or weekly, or bi-weekly. Okay, so that's mainly the difference, just so you're not confused. And of course, there's a lot of interaction. These 3 values, present value, payment, and future value, are where the amount go in. So for the compound interest, as you saw, the value is in the present value and the payment is 0. Whereas for the annuities, the payment has the value, the present value is 0. I hope that's a little bit just to clear up any doubts or you might have about what distinguishes compound interest from annuities.